Currently in the UK, passenger cars produce about 72 million tonnes of CO2. Over the past 10 years, that figure has actually come down by about 21%, mainly due to improvements in engine technology, vehicle dynamics and lightweight materials on vehicles. So a 1% improvement in fuel economy is representative of basically 750,000 tonnes of CO2 a year. The work that we're doing here at Bath with the Ford Motor Company is aiming to push that limit to 10%. If we can achieve a 10% reduction in CO2 from passenger cars and apply that to the entire vehicle market in the UK, we're talking about a significant reduction of approximately 7 million tonnes of CO2 per year.
The challenge for the car industry, and therefore the sort of things that we want support on from academia, is how do we introduce technologies that reduce the impact of vehicles.
Ford have sponsored projects here at Bath over the last 25 years, and we've seen that particular relationship develop more into a partnership. What the work has evolved over the last 10 years is really a very forensic approach to understanding how CO2 is generated from a diesel engine.
Well, it's a very wide-ranging project, but the thing that ties it all together is that we want to reduce the amount of fuel that's wasted that doesn't contribute to driving the car along the road. So there are lots of things that we can look at. For example, in the past we've looked at the accessory drive on the front of the engine. There's lots of pulleys, chains, belts and so on that drive engine accessories. If you can arrange that in a better way than it's done now, and if you can look at each part of that system and minimise the losses in that component, then altogether we showed during that work that you could save about 7% of the overall fuel consumption of the vehicle.
Here the emphasis is on a high level of understanding, whereas the emphasis within an industrial area is trying to develop product to launch, to get to customers.
I think it's very, very important to keep going back to the real engine or the real vehicle to check that the improvements that you're making are in fact real and that it's not just something that you see in simulation. So the rig that we're looking at now is a rig to evaluate the engine, just the engine. That's coupled to a machine which simulates the rest of the vehicle, and it's all controlled in a way that replicates what happens in real life. The advantage of doing it in a test rig is that the temperature is controlled, the work that the engine does is precisely controlled, everything is very, very repeatable from one test to the next. So that is a good way of spotting very small changes. If you change one aspect of the engine, which makes a relatively small difference to fuel consumption, we'll see that on the test very reliably. So in the chassis dynamometer that we have here, we can control the temperature in that room anywhere between -10 degrees C and +50 degrees C, and we can simulate going up hills, down hills. We can simulate any kind of driving that you would do in Europe, certainly. And that allows us to explore the effect of the changes that we're making in conditions such as you would come across in everyday life.
Downside of a lot of technologies that improve fuel economy is they cost huge quantities of money. So if you want to make impacts rapidly and quickly to reduce CO2 emissions from cars, probably the quickest thing you can do is to reduce frictional losses or to improve combustion efficiency, so other areas of parasitic loss. So that's most of the work that we're doing here. Now we're introducing technologies that give small gains, but are perhaps low cost, that we can introduce across a broad number of the products.
I would expect that the vehicles that we're driving around in 5 years will be quite noticeably different from the vehicles that you see on the road now. And these kind of improvements to the oil pump, the lubricant technology, accessory drives and so on, will become progressively more the norm as we go through the next 5–10 years.
The very nature of academic institutions, they are there to question things. So when we have a perceived view on things, it's very easy to get stuck in a rut and to think that it's right because you think it's right because everyone in the industry thinks it's right. Working with the universities helps you to question things you take for granted I think that's a great strength.
Developing, maintaining and sustaining links with industry is part of our core business. As a university, we're educating future engineering technologists and leaders and project managers. We need that engagement with industry. We need to know that what we are doing within our curriculum and within our research is directly benefiting both our products, which is our students, and also our research, which is fed into industry as well.
And for us, the work we do, the impact is in the form of getting our technology into vehicles, getting it sold, helping Ford to have a good business, but helping the consumers to have products that they need and want. And if we can do that, that's really very satisfying, because the research lives on in the form of technical publications. Yeah, that's great, but to see it out there in vehicles being used every day is I think, a really exciting outcome.